Right, so the first thing we're going to want to do for this equation, that it really needs to be a trinomial, is we need to make this minus, or this negative 25, a 0. And to do that, all I'm going to do is add 25 to both sides of the equation here. So that would be plus 25 there. And then here on the right, it's plus 25, but remember there's no like terms on either side of that. So I'm left with, well, we had to start with 64x squared minus 80x. And then I can show the plus 25. It's just now this is going to equal 0, okay? And from here we can solve. So as fun as that last one was for us, this one should be even more fun. So, but the thing on this one though, okay, that I first would notice on this one, again, I know it's equal to 0, so I don't have to worry about making it, forcing it to equal 0, that's fine. What I want to do is see if I can split this up kind of without having to factor by grouping, right? And what I see here is that the leading coefficient, 64, is a perfect square, but so is the 25. So I'm actually looking for one of those perfect square trinomial situations, all right? So let's see what happens. And so remember, that's something squared. In this case, it'd be minus 2 times something else times the last term squared. Now, of course, this will equal 0. I'm not worried about that right now. But the a value in this case, we would look at 64. What times itself 64? It's 8. And then, of course, we got the x. Okay, so you could even put that 8x right here. Remember, it's 2 times a times b. So I'm just making it the a value second. That's it. And then the b value in this case, 25, that would be 5 to the power of 2. So that's, it would be multiplied in the middle term. So would this work? Well, 2 times 5 times 8 is 80. And you can, we're not worried about the minus sign. Remember, that's part of the perfect square trinomial stuff, right? So this then means that I would then go look and see, look, we can make this, it's just, well, it's a perfect square trinomial. So I'm squaring this, and then it's going to equal to 0. And since we got a minus sign between the first and second terms, there'll be a minus sign here as well. Well, what's the first term? It's going to be 8x, and then the second part of that is going to be that 5 there in purple, okay? Now this, I mean, you could split this up into 8x minus 5 twice, right? Something like this. And this one, something like this, okay? And you could say, well, that's going to equal 0, and you could solve it twice. The problem is, it's the same thing twice on this one. So what this means is that we're going to end up with one answer. That's it. Only one answer, okay? I'll kind of show you why this is going to happen, although it may be getting a little bit ahead of ourselves, okay? So I'm going to look at this 8x minus 5, right? If I could just make that equal to 0, I'd get a true statement out of this. So I'm going to add 5 to both sides. 0 that out, drop my 8x, which then equals 5. Let's hope I can fit this in there, but I'd have to divide both sides by 8 now to get x equals 5/8. Okay, now, again, I'm only expecting one answer because both of my binomials, when I factored, is the same binomial. So what I should get from the original expression is a true statement just from this one answer. There's not actually a second answer here. So let's check. So 64 times 5/8, that's going to be squared. And then minus 80 times 5/8. And then plus 25. I push enter. And when I push enter, I'm expecting to see 0, right? It does. It equals 0. So that means that we did that correct. X equals 5/8. But again, this is the reason why there's only one answer here is because when we factored out the original expression, we ended up with the same binomial being both factors there, okay? So really this step right here was kind of obsolete, but I really do hope it helps us to see why there's only one answer on this, okay? Now, to kind of get a little bit of ahead of ourselves, these are what we call roots. So if you look at graphs, this is it's a parabola. Okay, so most parabolas, when they cross, we're looking at the x-axis, something like this. We're looking at where this crosses the x-axis. Those are called roots. Okay, and that's why we generally have two answers. But with a situation like this that has only one answer, This means that the parabola is just barely touching the very tip. And I know it's not a very good parabola, if you know what a parabola is, but I don't care. So it's just touching right there at one point, in this case, well, 5/8, whatever that is. Okay. Is it possible for this parabola not to touch the x-axis at all? Yeah, it is, but we shouldn't see anything like that. So perfect square trinomials, this is the rule. Actually, I need a little bit more space here. Let's see if I can fit this in. So it's a squared plus 2ab. I guess in this case it was minus, right? So I'll show this with the minus sign. Minus 2ab plus b squared. It's always plus b squared. What this allows us to do is to split this up into, well, I guess you could say two binomials, but you're going to take the a value and the b values and just sit them into this binomial right here. What happens is the middle term, the 2 is just saying that it's a double the a times b. And I know we saw a problem that was like this, but again, this kind of goes back to the rule, which we've seen more or less derived for us. Oh, sorry, that'd be a minus sign as well. But the 2 is part of the middle term, but all we care about is the a and b. So even though, yeah, we had this 2, that was just to show that it was in this format, allowing us to put it into this perfect square trinomial business with this binomial like this one. Yeah, just to kind of emphasize what's happening here, right? So if you look at what I have here expanded, and I would just look at the this set right here, right? So 8x times -5 would be negative 40x's, right? But you get the same thing from this. That's -5 times 8x, which would be negative 40x's. So that's why it's double a times b, because a times b is negative 40x, but we got to double it when we factor out, when we distribute between these two binomials.